where each bounce is a fraction of the previous bounce height. So that's going to be your constant multiplier, right? So apparently after 3 bounces, we're at 11.2 centimeters. That's going to be a little more than a decimeter. People don't talk about decimeters, but that's like 1/10 of a meter, right? And then 4.5 centimeters about. And, yeah, so what's the multiplier? You could use a calculator, but I can just see it in my head. I know, it's because I have great powers of computation. No,
Your brain is the calculator.
So, yeah, you see if I multiply this by 4, I get 44.8, but it's 1/10 of that, so I'm multiplying by 0.4, right? If I multiply by 0.4 again, I get, 1792 divided by 10, which is 1.792, right? Okay, so my multiplier is 0.4. So then, to go backwards, I multiply by the reciprocal of 0.4, which is 5/2. So, right, isn't that right? 0.4 is 2/5. The reciprocal of 2/5 is 5/2. So if I multiply this by 5, I get 56. Is that right? And half of 56 is 28. What's 5/2 times 28? Just going backwards here, right? This is 56, did I say? Oh, half of 56, which is 28. And what's 5/2 times 28? Well, that's going to be 70, right? 5/2 times 70. 35 times 5 is 175. 175, that's, 1 3/4 meters. That's about like so. So, you dropped the ball from a height about like this, and it came up to about 7/10 of a meter. And it came up to a little more than 1/4 of a meter. And that's probably a pretty good model for a bouncing ball. It loses energy on each bounce exponentially. And so what was the height? 175. What's the rebound ratio? 0.4. What's the model? Well, y equals, and they tell us to write y equals, and it's going to be the original height, 175, times 0.4 raised to the power x, right? So that's my multiplier is the 0.4, and I've got, after x bounces, I've multiplied by that x times. Yeah. So that should be good. Watch the video. Can you watch the video?
Yeah.
I suppose you can get it wrong. Who's doing the video? Oh, they got a little picture of a calculator over here.
Wait, hold on. Can you scroll down?
Sure.
175. Weird.
You doing something different?
No, I wrote in the same. Oh, no, I didn't write in the same thing. Never mind.
Uh-huh. Don't forget that little time sign there.
No, I wrote 174.
Oh.
There we go. Thank you.
All right, so number 2, it's too similar to number 1, we'll just move on, but no, it's different. Okay, so in the year 1999, age-adjusted death rate per 100,000 Americans for heart disease was 221.2. By the way, I don't think this is true, and what makes me say that is that this is a paramedically generated problem, so every time you do it, you get different statistics. And so the true statistics are probably, I don't know, you can look it up, I suppose. But suppose this were true. It would say, suppose that in the year 1999, in the year 2004, the age-adjusted death rate per 100,000 Americans for heart disease had changed. It's now smaller. It's 194.2. So what can we do? Well, we can gather our data in a nice chart where, I suppose, this is a good there's any. So I've got t and f of t. They ask us to use the function f, function name f. So we know that t is going to be years since 1999. So in 1999, it's going to be 0, right? So t equals 0 corresponds to 1999. Sure. And f of t is going to be the age-adjusted death rate. What does it mean, age-adjusted?
Wow.
For 100,000 Americans for heart disease. Maybe they don't, they don't include children. 221, huh? 0.2. So let's just write in the data. Okay, so we have 221. So 0, 221.2. And then in 2004, that's going to be t is 5, right? And we get 194.2. So there's our 2 data points. That's enough to determine an exponential function, right? So we're going to have f of t has the form f of 0, which we know, right? So that's 221.2 times some decay factor. So b here is going to be a number smaller than 1, because it's getting smaller, right? So we multiply by b 5 times, we get a little bit less than 221. So what is that? Well, so we can figure it out, right? We know that f of 5 is b to the 5th, 221, did I? 21.2, and that's going to be equal to 194.2, so we can complete the model like so. We get 194.2 divided by 221.2, and what is that? I don't know. My powers of computation fail me, so I've got to go to some sort of calculator, right? I'm going to enter in this computation, which is 221. Actually 194.2 divided by 221.2, is that right? Yeah. And so that's 0.8779. So what does that mean b is? Well, b is going to be approximately the 5th root.
Bless you. Thank you.